Today's video will describe how chemists can determine how much electricity can be made by or required for electrochemical cells. The cell potential for a chemical cell is calculated by using the reduction potentials from the reduction half reaction table that is found on page 7 of your data booklet. You'll need to look up the reduction potential of the oxidizing agent and the reduction potential of the reducing agent and subtract the two values. Although it is not commonly used, if you require the oxidation potential, you can reverse the sign of the value of the reduction potential. When the calculation for cell potential is completed, if a positive value results, then the reaction is spontaneous. If the result is negative, then the reaction would be non-spontaneous. This observation agrees with the previous rule that you have learned about spontaneity, which states that the strongest oxidizing agent must be above the strongest reducing agent on the reduction half reaction table. Standard cells are specific cells where all entities are at SATP conditions and the concentrations of aqueous solutions are 1.0 moles per liter. Standard cell conditions will result in standard cell potentials. The standard cell potential is the energy difference between the cathode and the anode. In building the half reaction table that you use, a standard hydrogen half cell was used. This is why the value is 0. All of the other values were measured in relation to this half cell. Here's a diagram showing the standard hydrogen half cell. It has hydrogen gas and an acidic solution along with a platinum inert electrode. If for some reason a different half cell was selected as a reference, the expectation is that the differences between all the values would remain the same, but there would be a shift of all values up or down depending on which half cell was selected. If you find the copper 2+ half reaction on your data table, you will see that it has a reduction potential of positive 0.34 volts. The positive number means that it has a greater tendency to gain electrons than hydrogen ions, which are in the reference reaction. This means that copper 2+ ions are stronger oxidizing agents than hydrogen plus ions. If you find the zinc half reaction on your data table, you will see that it has a reduction potential of negative 0.76 volts. The negative number means that it has a greater tendency to lose electrons than hydrogen gas, which is in the reference reaction. This means that zinc metal is a stronger reducing agent than hydrogen gas. Here's a table similar to the one found on page 7 of your data booklet. The values shown are for the reaction as written. If the reaction reverses, the sign of the reaction changes. If we change the coefficients of a half cell reaction, the value of the reduction potential does not change. There are two different methods that you will be able to use to figure out a cell's potential. The first one involves determining the half reactions and their corresponding potentials. Notice how the oxidation half reaction is reversed from how it is shown in the data booklet. When the half reaction is reversed, the sign changes from negative 0.76 to positive 0.76. This gives us a net cell potential of positive 1.10 volts. Because this value is positive, we know that this reaction would be spontaneous. In some cases, it is helpful to know a short method to find the net cell potential. Using the formula from the beginning of this lesson, substitute in the values for the two reduction potentials. The same value is obtained without quite as much writing. Please note that the cell potentials you can calculate apply to cells that are under standard conditions. There are many factors that may result in different values. Some of these include differences in concentrations, differences in purity of substances, and coatings on metal electrodes. Well done! We are already halfway through this unit.